Greetings and welcome back to Advanced Steel Design. We are continuing our discussion of fasteners. In this case, we are now moving on to the topic of welds. Having completed the section on bolts, we're now looking at the topic of welds. When we get to the topic of welds, there are a few terminology that you need to be familiar with. SMAW, or shielded metal arc welding, and of course SAW, which is submerged arc welding. In both of these, current arcs across a gap between the electrode and the base metal heats the connected parts melts the electrode which then gets deposited into the molten base metal. It's almost like you're making steel right there at that site. And then, of course, there's the material that you used for protecting the molten steel. For example, the shield. The shielded metal arc welding process, that shield comes about from the electrode, which melts, and the special coating vaporizes and forms a protective gaseous shield. And in the submerged arc welding process, you actually have a flux, a granular flux. In SMAW, a protective coating on the electrode vaporizes and forms a gaseous shield. And in the submerged arc welding process, you actually have a granular flux to form the shield. There are hundreds, if not thousands, of videos of this topic on YouTube that you can find and go through. And I'm sure you've had some experience of seeing welding being done, or you may have played with an electrode yourself. And when you played with the electrode, the stick electrode in particular, you realized how difficult it was keeping that gap, because there is a tendency to close the gap, in which case the electrode just gets stuck to the base metal and you're not doing welding anymore. But I guess the most important thing here is what is the weld electrode material. The weld electrode material, usually designated by E70XX, indicates that the tensile strength of the material is 70 KSI. That's the tensile strength of the most standard electrode. Now you can get E80XX, you can even get E100XX, but those require careful handling. You have to dry them out. And of course, you have to dry out the E70XX electrode too, but the E80 and so on require even more special handling. E70XX, or the 70 KSI electrode, is the most commonly used electrode when you're doing welding. Of course, the question becomes, what do I do, or what are the different types of welding that I can get involved with? So you can have a situation where you have two steel plates that have approximately the same thickness, and you can use what will be a complete joint penetration weld, in which case this is the plate of thickness T, this is the plate of thickness T. You'll have to use a small backing bar, otherwise your electrode will flow out. And then you can fill this groove with weld beads. Each weld bead, of course, varies depending upon the welder and the individual that you're working with. But typically the largest weld electrode bead, a single pass weld, the largest single pass weld you can get is about 5/16 of an inch. Which means that every time I make a pass, I can deposit a bead that's going to be approximately 5/16 of an inch. Of course, it's a slow process. If I'm using a 5/16 inch single pass weld, then it's going to be a very slow process of depositing that weld bead along the length of the member. If you specify a weld size that's greater than 5/16 of an inch, it means I have to do multiple passes. And every pass costs the same amount of money, which means that the cost of your weld is doubling every time I have to make a pass. So be careful when you specify sizes more than 5/16. I'll have to go through and make multiple passes. Besides that, I can also have a partial joint penetration weld, in which case I don't use the complete thickness of the material, but instead I use only a partial thickness of the material. I don't need an additional backing bar in order to secure this connection. I'll call that a complete joint penetration and a partial joint penetration weld. The thing with the partial joint penetration weld is that it will never develop the strength of the plate. What that means is that when I subject or when I pull these two plates apart by applying a force T, what am I going to get? I'm going to get fracture occurring right through the weld metal because my plate has got more thickness. The CJP, on the other hand, I can get, depending upon the relative strength of the electrode and the base metal. I'll call this the base metal, and I'll call this the electrode. As long as they are matched, the electrode will be just a tad bit stronger than the base metal, and I will get failure somewhere at the boundary of the base metal and the electrode. Clearly, the PJP is easier to perform because it doesn't need a backing bar. But it cannot develop the full strength of the plate because the failure will occur right through the weld metal, right through the weld thickness itself. But the most commonly used weld is the fillet weld.